So, hello everyone. Another precipitation presentation, but in a different horizon and domain. I would like to try to explain it. So, my name is Muhammad Usman Liaqat. I'm also working in CNR IRPI with Luca, and today I'm going to present a bit new thing assessing the impact of next generation gravity mission to estimate the precipitation over the Europe. Okay. So we normally all know that the GRACE satellite, like experiment, providing us the terrestrial water storage providing us terrestrial water storage from the regional to global scale. However, they lack the spatial temporal resolution that is challenging to make them to interrupt the different gravity field product. The next generation gravity mission and MAGIC are the upcoming satellite missions to overcome these challenges. The overall research objective is to examine the impact of spatial temporal resolution on GRACE by developing the multiple synthetic experiments over the European scales. Means that when these upcoming gravity missions will launch, how they will actually affect and providing us the new data sets that will be helpful to estimate the global fluxes, hydrological fluxes. So normally we know that the precipitation is estimated by the yeah. So normally we know that the precipitation is estimated by the rain gauge. And you guys already heard multiple times in last days about this SM2 rain model, where the precipitation is we measure by the reciprocal measure by using the amount by using the soil moisture from the subsurface. So by using the same model, we have first of all that is already been explained here multiple times in the last 2 days about this SM2 rain model that we are using it to estimate the precipitation. I will not go more detail about this model, but the main thing that I would like to emphasize here about this, how we are measuring and how it's overall we have developed the synthetic experiments. So at this time, we don't have the two terrestrial water storage that we have available. So what we are doing, we are developing the synthetic experiments and using these synthetic experiments to estimate the precipitation. First of all, we are using the soil moisture from the era 5, taking the mean over the 4 layers. And that we considering it is a terrestrial water storage. And this terrestrial water storage then is we have available at 1 day and 10 kilometer. First of all, we are checking its reliability. Either this terrestrial water storage can be useful to estimate the precipitation, because this is the first time that we are using the terrestrial water storage to estimate the precipitation. Generally, before we is normally using the soil moisture to estimate the precipitation. So the first thing is that we are here. We have the terrestrial water storage that we computed from the era 5. After first of all to check its feasibility, we put into the SM2 rain model, and then we have computed the simulated true precipitation that we have compared with the actual era 5 land precipitation to check the reliability. Later, we have introduced the different synthetic experiments like resampling it from daily to 5 day. That is the ultimate, the resolution of the next generation gravity missions, and also by adding the synthetic experiments like adding the Gaussian error to see how when these satellite launch, how the variability of these models can behave. And then these we will compare it with the like the GRACE like NGGM like with the simulated precipitation. For this one, we have used the time period from 2003 to 2012. So these are the initial results that we have computed it, first of all, to check the reliability of the model. By seeing the results, we have seen we can say that the total water storage is able to simulate the precipitation both spatially as well as temporally. That you have seen the results like both the high flow and low flow limbs here are able to capture the flow dynamics here, precipitation dynamics here. And similarly, we can also check the results spatially. And then here we have checked the results at the different points randomly over the Europe. Like for example, the one point here over the Germany, Spain, and Italy, where you can see that model is able to reproduce a precipitation by using this total water storage. After confirming the reliability of the model that is able to reproduce the precipitation, the next task is to varying the spatial temporal resolution and to see how it overall impacting the results here. So here you can see that we have taken the like the 5 random points over the different locations over the Europe, where you can see that like by varying the temporal as well as the temporal resolution and introducing the error, the reliability of the model. So you can see that overall, if you can see for I just give you an example, like here we have used the 4 different temporal resolutions, like at 5 day, 10 day, 15 day, 13 day, and then we have introduced the different errors. So the overall temporal resolution have a more impact over the results as compared to the errors. For example, at 5 day and introducing the error have a least impact, like have a more correlation and a lower RMSE as compared to the higher temporal resolution as and the lower error. So these are basically like at the different random points. But here, what I did, I used 100 random points over the Europe. So I think this slide is give us more good, impactful, showing the results for over the Europe, like by using the 100 random points over the Europe. So you can easily see that temporal resolution when I have like a 5 day, and even with a more error that introduce, we have a higher correlation and lower RMSE as compared to if we have a longer temporal resolution like a 13 days, then they have a lower correlation coefficient and higher RMSE. And these are some of the special results where you have seen that when while varying without error, and then with after introducing the error, how the model is behaving when without error, then model definitely is able to reproduce the precipitation, and when after introducing the error, the model the definitely the efficiency of the model is reduced. And then these are some also another results from the different projects, but the same thing is but just using the different data sets that we have, where you can see that here, for example, this one is the result from like we have already I mean just use the era 5 synthetic experiments, but here we have using from the different projects that using the reference data set and then reproducing the precipitation. And then these are the some of the results over the global scale, where you can see the like we have the like the different products, for example at Greece unfiltered filter data. So these filter and filter is basically different configurations that they have developers, and being as an end user we have the simulating how these total water storage is impacting to reproduce the precipitation. So by looking these results we have sorry. By looking these results, we can see that the NGGM is able have a more better results to simulate the precipitation-based terrestrial water storage, followed by the MAGIC and GRACE mission as compared to their unfiltered configurations. So the take-home messages for my presentation is, first of all, terrestrial water storage is able to reproduce the precipitation. Initially, that the essence only that we in our research that we are using the soil moisture to reproduce the precipitation, but the next thing that is a bit new thing is that now the terrestrial water storage is also able to reproduce the precipitation. The next is about the temporal resolution. So we can conclude that the higher resolution, like I mean a 5 day temporal resolution, have a better results as compared to the 13 day temporal resolution to reproduce and have a higher correlation as compared to lower RMSE. The last thing is about the improved temporal resolution of the next generation NGGM provide us some more good results to reproduce the precipitation followed by MAGIC and GRACE filter. Thank you so much.
Okay, let's see if there's some questions for Muhammad. You have a publication also behind this work, or
Yes, we have already, presented in different conferences. And recently, we have submitted into the HES about for this over
okay,
the European scale. Yeah.
okay. Okay, if there's no more questions, we can proceed with the last presenter. Thank you.